The system of coordinates. On the basis of the physical interpretation of distance which has been indicated, we are also in a position to establish the distance between 2 points on a rigid body by means of measurements. For this purpose, we require a distance, rod S, which is to be used once and for all, and which we employ as a standard measure. If now A and B are 2 points on a rigid body, we can construct the line joining them according to the rules of geometry. Then, starting from A, we can mark off the distance S time after time until we reach B. The number of these operations required is the numerical measure of the distance AB. This is the basis of all measurement of length. Note, here we have assumed that there is nothing left over, that the measurement gives a whole number. This difficulty is got over by the use of divided measuring rods, the introduction of which does not demand any fundamentally new method. End of note. Every description of the scene of an event or of the position of an object in space is based on the specification of the point on a rigid body of reference, with which that event or object coincides. This applies not only to scientific description but also to everyday life. If I analyze the place specification Trafalgar Square, London, UK, I arrive at the following result. The Earth is the rigid body to which the specification of place refers. Trafalgar Square in London is a well-defined point to which a name has been assigned, and with which the event coincides in space. Note, it is not necessary here to investigate further the significance of the expression coincidence in space. This conception is sufficiently obvious to ensure that differences of opinion are scarcely likely to arise as to its applicability in practice. End of note. This primitive method of place specification deals only with places on the surface of rigid bodies and is dependent on the existence of points on this surface which are distinguishable from each other. But we can free ourselves from both of these limitations without altering the nature of our specification of position. If, for instance, a cloud is hovering over Trafalgar Square, then we can determine its position relative to the surface of the Earth by erecting a pole perpendicular on the square so that it reaches the cloud. The length of the pole measured with a standard measuring rod S, combined with the specification of the position of the foot of the pole, supplies us with a complete place specification. On the basis of this illustration, we are able to see the manner in which a refinement of the conception of position has been developed. A. We imagine the rigid body to which the place specification is referred, supplemented in such a manner that the object whose position we require is reached by the completed rigid body. B. In locating the position of the object, we make use of a number, here the length of the pole, measured with the measuring rod, instead of designated points of reference. C. We speak of the height of the cloud even when the pole which reaches the cloud has not been erected. By means of optical observations of the cloud from different positions on the ground, and taking into account the properties of the propagation of light, we determine the length of the pole we should have required in order to reach the cloud. From this consideration, we see that it will be advantageous if, in the description of position, it should be possible by means of numerical measures to make ourselves independent of the existence of marked positions possessing names on this rigid body of reference. In the physics of measurement, this is attained by the application of the Cartesian system of coordinates. This consists of three plane surfaces perpendicular to each other and rigidly attached to the rigid body. Referred to a system of coordinates, the scene of any event will be determined for the main part by the specification of the lengths of the three perpendiculars or coordinates x, y, z, which can be dropped from the scene of the event to those three plane surfaces. The length of these three perpendiculars can be determined by a series of manipulations with rigid measuring rods performed according to the rules and methods laid down by the Euclidean geometry. In practice, the rigid surfaces which constitute the system of coordinates are generally not available. Furthermore, the magnitudes of the coordinates are not actually determined by constructions with rigid rods, but by indirect means. If the results of physics and astronomy are to maintain their clearness, the physical meaning of specifications of positions must always be sought in accordance with the above considerations. Note, a refinement and modification of these views does not become necessary until we come to deal with the general theory of relativity treated in the second part of this book. We thus obtain the following result. Every description of events in space involves the use of a rigid body to which such events have to be referred. The resulting relationship takes for granted that the laws of Euclidean geometry hold for distances, the distance being represented physically by means of the convention of two marks on the rigid body.